Your AI model is running. One user sends a request. 500 milliseconds later, the response is back. Beautiful. Now 1,000 users hit at the same time, and suddenly user number 100 is waiting 50 seconds. Welcome to the batching problem. Here's a dirty secret about LLM inference. A single request barely uses your GPU. One user's token generation is a matrix vector multiply. That's like hiring 16,000 workers and giving one of them a task. Your A100 is 92% idle. You're paying $32 an hour for a GPU that's mostly sleeping. The simplest fix is static batching. Collect N requests and process them together. But it has a fatal flaw. Short requests have to wait for long ones. Request D needs only 30 tokens, but sits around while request C generates 150. The GPU wastes compute on padding tokens for the shorter sequences. Enter continuous batching, the game changer. Instead of waiting for a whole batch to complete, the system works at the individual token level. At each time step, generate one token for every active request. When a request finishes, remove it. When a new request arrives, slot it in immediately. The GPU is always processing a full batch. No idle time between requests. This is exactly what makes vLLM and TGI so much faster than for multi-user serving. The difference is night and day. Dynamic batching sits in front of the inference engine. It collects incoming requests using a time window, say 50 milliseconds. Requests A, B, and C arrive within that window, get grouped, and sent to the GPU together. You configure the max queue delay and preferred batch sizes. Now here's the fundamental trade-off, throughput versus latency. On an A100 with Llama 3.18b, throughput increases 27x from batch size 1 to 128, but per-user token speed drops from 95 to 20 tokens per second. The sweet spot, batch size 32 to 64, high throughput, acceptable latency. LLM inference actually has two distinct phases that batch very differently. Prefill processes all your input tokens in parallel. It's compute-bound and loves batching. Decode generates output tokens one at a time. It's memory bandwidth-bound because it has to read the KV cache at every step. Mixing prefill and decode in one batch creates a scheduling nightmare. A big prefill can stall ongoing decode operations for 50 milliseconds, making mid-response text feel janky. The solution is chunked prefill. Break long prompts into smaller chunks and interleave them with decode steps. For production deployment, gives you all the knobs. Set max concurrent requests, total tokens per batch step, enable chunked prefill, and control GPU memory utilization. For bigger models, use tensor parallelism to split across multiple GPUs. For really high traffic, run multiple vLLM instances behind a load balancer. Use least connections routing so each request goes to the instance with the fewest active connections. 3 instances of 4 A100s each can handle serious production load. 3 metrics you must monitor in production. Time to first token, target under 500 milliseconds. Inter-token latency, target under 50 milliseconds so it feels like smooth typing. And total throughput in tokens per second across all users. These tell you if your batching is actually working. Let's recap. A single request wastes 85% of your GPU. Continuous batching is non-negotiable for production. Throughput scales 20 to 30x with proper batching, and always separate your prefill and decode scheduling with chunked prefill. Next episode, speculative decoding, using a small model to draft and a big model to verify for 2 to 3x speed gains.